Hey, Walter Sorrells back with more tips for the knife maker. Today we're continuing our series about making wood turning tools, and I'm going to make a 1/2 inch spindle gouge. There are a number of different types of wood turning gouges made from cylindrical stock. The primary differences between them are, first, the profile of the slot or flute cut down the center of the tool, and second, the type of grind made to their face. What we're going to do in this project is a spindle gouge, but you'd be able to use very similar techniques to produce a bowl gouge, which had a much deeper flute. If you watched our earlier spindle gouge video, the end result is actually going to be fairly similar, though this is a much smaller tool. But the way we get there is going to be a little bit different. Also, I'm using a type of steel that we have not used in any project so far. So for this project, we're using a tool steel called 01. 01 tool steel is very commonly available in drill rod. The good news is that 01 is one of the easiest, most forgiving steels there is to heat treat. But we'll talk about that later. Alright, let's get started. We'll start things out by doing the exact same thing we did on the earlier gouge. We're going to flatten a face to give us a reference surface. Once we've got it flat, we're going to move up the grits and smooth it out a little bit. Now we're going to rough out the flute. So we're going to do that by milling out the slot in the center using a ball end mill. A lot of you probably don't have a mill. So could this be done with a file? Sure. You could do essentially the same thing that we're going to do using a chainsaw file or a round file. Would it be a lot of work? Absolutely. But you can do it by hand if you want. So here we go. We've got our stock set up in the milling vise, and we're just going to mill out the flute. One of my general points that I've been making in this series is that there's more than one way to do almost everything. So if you don't have a mill, no problem. There are a ton of other ways to do it. By varying the size of the mill or file that you use, you can actually make a bowl gouge this way. The difference between a bowl gouge and other gouges is that it has a deeper, thinner flute than other gouges. So if you use a thinner mill or a thinner file, cut a nice deep flute, then you got a bowl gouge. That's not what I did, but you can see how it would work. I'd probably want to do this with slightly larger stock though, something around 5/8 of an inch, and I'd need to take several slow passes. I'd probably want to use a regular mill for the first few passes, then I'd switch over to a ball end mill of the same diameter for the final pass or two where I'm milling the round bottom of the flute. But that's not what we're doing here. We're just making a spindle gouge, so we're using a slightly larger ball end mill, and we're going to end up with a slightly larger radius to that flute. Now I'll go ahead and grind the cutting edge. You can see my earlier spindle gouge video for details on how this geometry works. Check out that video here. It's basically the exact same thing, but just slightly smaller. So, the milling's complete. Now it's time to heat treat. 01 is solidly in the oil hardenable camp, so we can harden it in transmission fluid, peanut oil, mineral oil, or elephant snot, and it'll pretty much harden okay. Now, some professional metallurgist is probably going to post a nasty note saying that actually there's a lot more to it, and lamellar annealing and nucleation and grain boundaries and so on and so forth. All true. But for this video, that's all beside the point. The whole point of this video is to show you an approach that will work for people who don't have industrial quality heat treating equipment. And the fact is, with fairly imperfect heat treating methods, 01 will still yield quite good results. Okay, we'll heat it up to non-magnetic and a little beyond, just like we did all our 1095 tools. We're shooting for around 1500, 1550. I'm skipping the elephant snot here and quenching into warm peanut oil. Watch out when you do this, because sometimes it'll flame up, so don't do this in your kitchen or while filling the gas tank of your car. I'm only immersing the cutting part initially, not the shank. You want the shank to stay soft and shock resistant. So you're going to keep it warm for a little longer before you finally immerse the entire tool in the oil. After we've gotten it to a temperature that we can touch the tool, we'll pull it out, we'll file test it to make sure it's hardened properly. Check, then temper it 2 cycles an hour each for 400 Fahrenheit, just like we did the 1095 in the other videos. Clean it up. I just use sandpaper and liberal applications of elbow grease. Now I'll put a handle on it. This one's made from leopard wood. Pretty darn cool looking wood. By this time, you've seen me make a bunch of handles, so I'm not going into too much detail, except to say that I finished it with nitrocellulose lacquer, just the same as I did for the Spindle handle for the skew chisel. Again, nothing particularly new here. If you've been watching this series, we're going to make the handle in exactly the same way that we've done all the ones previously. Putting on the ferrule, epoxying everything together, and driving that tool into a hole bored down the center of the handle. And there we have it. If you enjoyed this video, please subscribe to my channel and check out my website, waltersorrellsblades.com, where you can find more of my work. You'll also find plenty more videos there that you can't find on YouTube with very, very detailed information about all aspects of Japanese blade making. Also, like me on Facebook at Walter Sorrells Blades.